Today we're going to be learning about the shape of distributions. Now, this is generally going to be used with either dot plots, box plots, or histograms, and whether or not it's grouped to the right or the left or in the middle. So the shape of a distribution, if it talks about the shape, it's just how the data is grouped. Okay, so there are three options. It could be grouped to the right here, grouped to the left, or grouped in the middle. So that is what we mean by the shape. Now, skew means that the distribution is pushed to one side or the other. So the distribution is pushed to one side or the other. Now, be careful with this. It is the opposite of what you might think. So the first one here, we have a right skewed. Now, you might think that skew means pushed to the right, but it's actually opposite. If you notice, the hill here is to the left. Okay, so right skewed has mostly lower values with a few high values. Okay, so notice there's a note here that says outliers are at high values. So there's a lot of low values and just a few high values. Now, in the middle here, there are three lines. Okay, there's actually three lines in the rest of these. These represent the mean, median, and mode. So they might ask you, like, is the mean greater or less than the median? Well, here's how you can tell. So draw three lines on the hill going down towards the tail. Okay, the highest line here is going to be your mode. So mode is the most, so it went up the most. The middle one is your median. Okay, median means middle. And then last one is going to be your mean. So mode is the most, median is the middle, mean is the other. Okay, so this would be like if it was a histogram. So there's lower, goes up even more, and it starts going down lower and lower and lower. So all of the data is bunched to the left here, making it right skewed. Okay, left skewed, it's pretty much the same thing, except the opposite. So it's mostly high values with a few low. Okay, so mostly high values, same three lines, mode is the highest, median is the middle, mean is the other. Okay, and our outliers, things that are going to be low values. There's not going to be very many of them. Symmetric means it's all bunched up in the middle. So there's actually three lines here. Your mean, median, and mode are all pretty much the same. Okay, so now this is what the hills would look like if it was a histogram. If it was a box and whisker plot, it would be still, for the right skewed one, your box would be shifted to the left and there'd be a pretty long tail out to the right. For the left skew, your tail would be to the left, then your box and short whisker would be to the right. And symmetric, everything would kind of be spread out pretty evenly towards the middle. So that is our shape of our data. All right, the next thing is going to deal more with dot plots. Okay, so when you see a dot plot or a scatter plot, it depends on, or what it looks like can tell you a little about how things are related. So two words you might see, correlation or association. They pretty much mean the same thing. It's just talking about the relationship between two variables. Okay, so the example that they give in the textbook is like the relationship between the amount of sun and the temperature. Okay, other things that go along with scatter plots are, one is the line of best fit, also called a trend line. And this is just a line that shows the general direction of data. Okay, it goes through the points as evenly as possible. Okay, so I'm going to draw a little picture right here. For example, like if there was a scatter plot, looks like this, your trend line would kind of go up through the middle where there's just as many above it as below it, and try to go through. Okay, the correlation coefficient is a number that tells like how strongly related the two letters are, or the two variables. So if all your dots almost make a straight line, as pretty close, kind of like this did here, your correlation coefficient is going to be larger. If the numbers are pretty random and it's kind of hard to tell where a line might go, your correlation coefficient will be smaller. Okay, so correlation coefficient is represented by the letter R. Okay, it's going to be a number between -1 and +1. Okay, now, please be careful with this. -1 is actually a strong correlation. It's just strong negative. +1 is strong. It's strong positive. Okay, so this number shows the strength of the relationship. So the closer your number is to to -1 or +1, the more likely that those two things are related. Okay, so it shows the strength of the relationship. So if it's -1, that's going to mean that it's a strong negative correlation. Okay, strong negative correlation. Now, negative correlation does not mean that they're not related, so please be careful. Close to +1 is going to be a strong positive correlation. And if it's close to 0, it's going to be a decimal, so like 0.2, -0.3. It's going to show that it is a weak correlation. So there's almost no real relationship there. Okay, now, in Desmos, they might ask you, like, what is the correlation coefficient, or how strong of a correlation is this data? So if you were doing it in Desmos, you type in the data as a table, and then you create a new equation that has y1 squiggly mx1 plus b. Okay, so what this is going to do, if you were to just type in, so here's my Desmos. If I add a table real quick, okay, I'm just going to put some random numbers. So 1, 2, 4, 6, 5, 8. Okay, then 5, 6, 7, 8, 9, 10. Okay, so if I look here, here's my dots. They're pretty much grouped together. They kind of go in this upward trend. Now, if I want to see how closely they are related, I go to a second line and type Y1. Okay, I need the little squiggly line. Okay, so if I go to the keyboard and push the letters button here, which is, there's a squiggly line right there. MX1 plus B. So I type it all in. Notice I have R squared and R. So R is equal to 0.95. That's really close to positive 1. So it shows we have a strong positive correlation. Okay? If I wanted to come up with the actual equation of the line that it puts for me, M, which is the slope, is 0.69, and B, our y-intercept, is 4.51. All right, flip your page over. There are 3 types of associations. There's positive, negative, and no association. So a positive association, if you had a graph, the dots are kind of going in an upward direction. They don't need to be in a perfectly straight line, but you could generally see that it's going up. So it trends upward. So what a positive association means is as X goes up, so does Y. Okay, so if X is going up, Y is also going up. Okay, the R value is close to positive 1. Remember, R is your correlation coefficient. Okay, next one, our negative association. So if we have our scatter plot, it's generally going to be going in a downward direction. So it starts high on the Y, goes down. Okay, so as X goes up, Y goes down. So they're kind of opposites of each other. Okay, it trends downward. Okay, now please be careful of this. Make yourself a little note. Negative does not mean that there's no association or correlation. Okay? Negative just tells you the direction it's going. It does not mean that there's not an association. Okay? For this one, R is close to negative 1. All right, last type. If there's no association, you won't be able to tell if it's going up or down, or it might be going up and then back down. The dots are kind of just random, so I don't know if it's going up and down or where it's going. Okay, as X goes up, you can't tell what happens to Y. Okay, R is close to 0. Okay, so can't tell where my line's going. It might be going up, it might be going down. If you were to try to put these points into Desmos and you did your Y1 squiggly line MX1 plus B, you would get that R value and it would be like 0.2. 0.1. It would not be a number close to positive 1 or negative 1. It would be close to 0. Okay, that is correlations and associations.